a straight line capital PQ inclined at 40 degrees to VP, inclined at 40 degrees to VP, has small PQ which is 60 mm and P dash Q dash is equal to 50 mm. The NP is in both HP and VP and 40 mm to the right of left profile plane. Draw the projections of the straight line capital PQ and find the true length and true inclination with HP, and also draw the profile view of the straight line and find the position of the NQ with both HP and VP. So as he has given all the distances, here he says the NP is in both HP and VP. As we have seen, the NP is in both HP and VP and 40 mm to the right of left profile plane. So we have the left profile plane to this towards the right side. You will consider, so point P is in both HP and VP. So obviously P dash is on XY line and P is also on XY line. And the 40 mm to the right. So here he has given the line is given here. So 40 degrees to VP, and he has given the top view and the front view. When the front view is parallel to XY line, its corresponding top view will going to be the true line. So that should be the condition which you need to apply. So when P dash is on XY line, so Q1 dash should also be on XY line. So P dash Q1 dash is the line which is front view distance. So you take 50 mm. So from P dash you measure the distance of Q1 dash, which is at a distance of 50 mm on the XY line, and then draw a vertical line here. Once you draw this, then so since the line is parallel to HP, correspondingly the line will going to be in the true length in the HP. So we know the true inclination with respect to VP, so that will be seen in HP. So from P dash you measure an angle of 40 degree and draw an inclined line so that it will going to cut this end projector at this point. So now you got the locus of Q in the top view. So we got this Q1 here. So this capital P, capital Q1 is also, because P is on HP, so Q1 should also be on HP, then only the line is parallel to HP. So we got PQ1 now. So now once we got the locus of Q in the top view, so we know the top view distance, which is 60 mm, with P as center, taking the radius of 60 mm, cut an arc, so you're going to get PQ. So we got the top view. So once you got the top view, so then from Q you draw a vertical projector to this, and then you draw a horizontal, but again vertical projector in the vertical plane, and then you with P dash as center, taking the radius of P dash Q1 dash, which is 50 mm, and draw an arc such that it will go to cuts on the locus of cuts on this end projector, so that you will going to get this Q dash. Then join P dash Q dash, which will going to be 50 mm. So you got this and we got this. Once you got these two lines, so you're going to get the line in space. Once you get the line in space, now we need to find out the true lengths. To find the true length, so with P as center, now the line in space is PQ. With P as center, rotate the line PQ such that it is parallel to VP. So P is on VP, capital Q should also be on VP. So you're going to get this Q2. Now the line is we have the locus of Q in the front view. So P dash and Q2 dash will be on VP. So we will get the true length here. So as we rotate like this, so what happens? The top view point also PQ on the, which is on the horizontal plane, you make it parallel to both. Q2 is also on VP, because P is on VP, Q2 will also be on VP. So now the line is parallel to VP, and when it is projected onto the locus of Q in the front view, you will going to get the true length here. So we got P dash Q2 dash. Similarly, if you want to find the true length in the true inclination is already given, so obviously we have found out the true length in the horizontal plane. So when PQ is rotated with P as center, PQ as the radius, when you rotate it and make it parallel to HP, so P is on HP, so Q1 is also on HP, so you are getting the true length. So this is how we can be able to analyze this problem in 3 dimension. So when you are projecting from P here, so it will going to come to this P double dash, and when you are drawing a Q2 dash, so here you are drawing a horizontal projector from here, and also you will going to get this point. How? So from Q dash you draw a projector, and from here you draw this, And similarly from Q1 you draw, from Q you draw this until here you get this point. So the image which is going to be seen, Q double dash, so that is, I'm looking from the right side view, so that image will going to fall here on the left profile plane. You will going to get this distance P double dash, Q double dash. Then you measure this horizontal distance and also this vertical distance. That is what he has given with respect to both HP and VP. So with respect to HP is this distance, with respect to VP is this distance. So this is how you will be able to find the distances. Now this is what we have seen in the orthographic view. So first we are going to take up the step by step. So initially what we can do is NP is in both HP and VP, and it is 40 mm to the right of left profile plane. So you are going to get this P dash. Then we know that when the front view line is parallel, its corresponding top view will going to be in the true length. You know the front view line which is 50 mm. So from P dash you measure 50 mm and draw a vertical projector. So we know that 40 degree is inclined to VP, which is the true inclination. So when you draw a line from 40 degree line here, so it will going to cut on this end projector, you will going to get the locus of Q in the top view. So that is what we have shown here. So we made that front view line parallel. So P dash Q1 dash is the distance which is 50 mm, and draw a vertical projector here. Then with P as center, 40 degree line, you draw a 40 degree line so that it will going to cut here. So this will going to be Q1. So you will going to get the dashed out line which will going to be the locus of Q. Now once you get the locus of Q, so that is what we have rotated and make it parallel. So you will going to get the inclination. So in the second case, what happens is, so once you get this, so we have the locus of Q in the top view, but we know the top view distance. So you cut it on this, you will going to get the top view. Once you get the top view, so the end projector of the front view point of Q dash should lie on this end projector. So from here you draw a vertical projector here, but it is already, you know that 50 mm length in the front view. Some P dash you cut an arc, so you're going to get the locus of Q in the front view also. Then with so to find out the true length in the vertical plane, you make that line, top view line, make it parallel to VP. So P is on VP, Q2 should also be on VP. So you make that PQ2 parallel to VP, then you project from here so that it will going to cut the locus of Q in the front view here, and you mark this point as Q2 dash and then draw this line. So since this line is parallel to VP, so this will going to be the true length. So you mark this as P and Q. So this is how you will be able to analyze this in 3 dimension. So as we have shown in the orthographic view, so we can see here the line which is in space, P, capital P and Q, which is rotated and make it parallel. So P is on VP, Q2 is also on VP. Therefore, P dash Q2 dash will be on true length. So this is how we can be able to analyze both in orthographic and as well as in 3D. Now we will go to solve the problem in the sketchbook. First we will go to draw the XY line and X1Y1 line, because we need to find the position of the NQ with both HP and VP, and also he has given 40 mm to the right of left profile plane. So from here, from X1Y1 line, you measure 40 mm towards the right side and mark the point on the XY line, because NP is in both HP and VP. Since NP is in HP, so obviously the image can be seen in the vertical plane. So you mark that as P dash, and on VP, so since it is on VP, the image will going to fall on HP, so it will going to be the top view. Then as we know that he has given the true inclination with respect to VP. So since the true inclination with respect to VP is given, so its corresponding front view will be in true length. You know the length of the front view, which is 50 mm. So from P dash, you measure a distance of 50 mm and mark this point as Q1 dash. So both P dash and Q1 dash is on parallel to HP. So its corresponding top view will be in true length. So since it is parallel to HP, so we can see the true length in HP. So the true inclination with respect to HP, that is VP, which is 40 degrees, the true inclination with respect to VP can be seen in HP. So from P, by using the protractor, you measure an angle of 40 degrees and then draw an inclined line such that it will go into cut this end projector here. So you mark this point as Q1. As we know that P dash and Q1 dash is parallel to XY line, so its corresponding top view, so capital P in bracket and capital Q is in bracket. Then join P and Q1 with little bit thicker than the XY line and then draw a horizontal dash dot line in the top view. So you're going to mark this as locus of Q. So we know the top view. The top view distance is 60 mm with P as center. By using the compass, cut an arc on the locus of Q and you mark this point as Q and then join P to Q with a dark line. Then as we know, so once you get the top view, you draw a vertical projector from Q to the front view. We know that P dash Q dash, which is P dash Q1 dash is the distance, which is 50 mm, which is the front view. But the front view should not lie, the Q1 dash of the front view should not lie on the XY line, but instead it should lie on this end projector. So with P dash as center, taking the radius of P dash Q1 dash by using the compass, you draw an arc such that it will go to cut the end projector at this point and you mark this point as Q dash and then draw a horizontal dash dot line and you mark this point as locus of Q and join P dash Q dash with a dark line. So we got the locus of Q in the front view. Now we have to find out the true length in the front view. To find the true length in the front view, you have to take the top view line. So with P as center, taking the radius of PQ, which is 60 mm, draw an arc such that P is on VP or P is on XY line and Q2 should also lie on the XY line. So draw, once you get this point Q2, then you mark this point as Q2. So both P is on VP, Q2 is also in VP. Now the line is parallel to VP. Since the line is parallel to VP, so you're getting the true length in the vertical plane. With Q2, from Q2 you draw a vertical projector such that it will go into cut the locus of Q in the front view. So you mark this point as Q2 dash. As PQ2 is the line which is parallel to XY in the front view, its corresponding line will be in true length. So you mark P dash and Q2 dash with little bit thicker than the XY line. And then and you mark this as capital P and capital Q. So this will going to be the true length. So now we need to find the profile view. So draw a 45-degree line from the origin adjacent to HP and then draw a horizontal projector from P dash to the origin and you mark this point as P double dash. And then from Q you draw a horizontal projector to the 45-degree line and from here 45-degree line draw a vertical projector to the profile view and then draw a horizontal projector from Q dash such that both will going to intersect at this point in the profile view. So you mark this point as Q double dash. Then join P double dash Q double dash with a dark line. So as we to find out the distance between, find the position of the NQ with both HP and VP. So from here you measure this distance and you mark this as V is equal to question mark, and from here to here this distance as H is equal to question mark. So this V is the distance above HP, H is the distance in front of VP. So by using the scale you measure the distance. H will be equal to 42 mm when you are doing it in manual. When you are doing it in computer it will be 41.95, and V, the distance when you are measuring it in scale it will be 26 manually. When you are doing it in computer it is 25.69. So by using the scale you measure the true length on the front view or on the top view. So true length will be equal to 65 mm when you are doing it in manual. When you are doing it in computer 65.27. And similarly the true inclination with respect to HP by using the protractor with P dash as center with respect to the XY line, you measure the angle. It will be 23 degree when you are doing it in manual. When you are doing it in computer it will be 23.18. So this is how we will be able to solve the problem in the sketchbook.